Hi, today we're going to learn about systems of linear equations in three variables. So I'm going to solve it in two different ways. So in this section I will solve a system of linear equation in three variables by elimination, substitution, and the other way would be linear algebra way. For the linear algebra way, I will put it in a reduced row echelon form and use the row of operations. So the first way we're going to do just regular elimination and substitution. So we're given system of an equation in three variables. So we have three variables, x, y, and z. First step I would do is I would label each equation system of equation by 1, 2, and 3. We'll just label this 1, 2, 3. So yeah, so it doesn't get confusing. So let's look at okay, so we have x. Let's look at the first equation 1 and equation 2. What can we get rid of? Let's get rid of a z. So how would I get rid of a z? I would have to multiply equation 2 by -2, right? -2. So the top equation number 1 stays the same, so I'm just going to rewrite it as x plus y plus 2z equals 7.5. And then equation 2 is going to be, I'm going to multiply that by -2, so it's going to be -6x, -8y, and then -2z equals -24. Now the z's cancels, right? So you're left with now if you were to add those two equations, if you would add this would give us -5x minus 7zy, 7 minus 7y, not zy, minus 7y equals a -16.5. Right, 7.5 minus 24 is -16.5. Okay, so this is our new equation. We can label this equation, we'll do letters, A. Now what I want to do is, so we have -5x minus 7y equals -6y. Let's get rid of another z, so how would I do that? Okay, so let's look at the equation 2. We have 3x plus 4y plus z equals 12, and then 5x plus 2y plus 5z equals 21. Let's get rid of the z's. So how would I get rid of the z? I can multiply equation 2 by -5, right? So instead of -2, let's multiply that by -5. And then I will put it right here. So -5 times 3x is -15x. And then -5 times positive 4y is -20y. And then -5 times z is -5z. And then -5 times 12 is a -60. Now I'm just going to bring down equation number 3. So it's going to be 5x plus 2y plus 5z equals 21. So what did we say the z's cancels? If we were to add these, the z's cancels. So you're left with -5x, no, -10x, sorry. -20 plus 2y is -18y equals -60 plus 21 is -39. And then we can label this equation label B. So let's look at equation A and B. They have an x and a y. We have an x and a y in equation B as well. So let's do elimination. So I'll put it right here on the right. So equation A is negative 5x minus 7y equals negative 16.5. And then equation B is negative 10x minus 18y equals negative 39. So what do we want to get rid of? Let's get rid of the x's, right? How do we get rid of the x's? We have to multiply the top equation, or equation A, by negative 2. So if we distribute that negative 2, it's going to be positive 10x plus 14y equals 33, right? If I distribute this negative 2 to the first equation A, and then I'm just going to bring down equation B, which is negative 10x, negative 18y equals negative 39. The x cancels. So you're left with 14x minus 18x, which is, if you were to add these, you get negative 4y equals, so 33 minus 39 is negative 6, divided by negative 4. And then y should give us 3/2 or 1.5. It's the same thing. So what I'm going to do is plug in y into the equation A, the original equation A, not the manipulated one. So this one, without the negative 2 distributed. So it's going to be negative 5x minus 7y, which is 1.5, right? Equals negative 16.5. So negative 7 times 1.5 is negative 10.5 equals negative 16.5. So we're going to solve for x, so we're going to add 10.5. So we're left with negative 5x equals 10.5 minus 16.5 is let me get my calculator. It should be negative 6. Divide both sides by negative 5. So x equals 6/5 or 1.2. Now let's solve for z. So how we can solve for z if we put it back into the first equation, equation 1. So right, we know our x and we know our y. So our x is 1.2 plus y is 1.5 plus 2z. 2z equals 7.5. 1.2 plus 1.5 is 2.7 plus 2z equals 7.5. Subtract 2.7 by both sides. 2z equals, okay, so 7.5 minus 2.7 is 4.8. Divide everything by 2. And then you get z equals 4.8 divided by 2 is 2.4. So our solution set is, I'll put it right here, is 1.2, 1.5, because y is 1.5, and our z is 2.4. And I've already put it back into the equation, and they all add up to give you 7.5, so I know this is true. Okay, so that was the algebra way. Now there's another way called, it's using linear algebra, right? And if you don't want to do linear algebra, you could just stop here. If you guys are learning linear algebra and you really want to do it, solve the system equation with linear algebra, then let's proceed. So yeah, we're gonna have to put this in a matrix, right? We're either gonna put it in okay, so yes, let's put it in the matrix. So to put it in the matrix, we do it goes by row by column. So let's look at our row. How many rows do we have? 1, 2, 3. So it's going to be a 3 by, and then it goes by column. So 1 column, 2, 3, 4. So our matrix is going to be a 3 by 4. So what we do, so we look at this equation. How do we just put in the coefficient? So this is a 1, this is a 1, this is a 2, and this is going to be a 7.5. So it's going to look something like this. So 1, 1, 2, and then the dash 7.5. What about this part? This is going to be 3, 4, 1, and 12, right? So this is going to be 3, 4, 1, because this is an invisible 1, and then 12. And what about here? 5, 2, 5, and 21. So it's going to be 5, 2, 5, and 21. And is this a 3 by 4 matrix? So does it have 3 rows? 1, 2, 3? Yes. Does it have 4 columns? 1, 2, 3, 4. Yes, so it's definitely 3 by 4. Okay, so what our goal is, we either want it to look like this. Would be this, we'll call this number 0, 1, 0. No, actually this is going to be 0, 0. And then that would be number 0, 0, 1 number. So if we're basically getting a diagonal of 1, and the rest over here, so this would be 1, 1, 1, and then the rest would be 0, 0, and this will be a number, not 0. This will be a number, this will be a number. This is what's called a reduced row echelon form. Reduced row echelon form. Also known as Gauss-Jordan elimination. And this is all in linear algebra. Or we can also make our matrix look like this. This is what I'm going to use row echelon form because it'll probably do, there will be if you didn't want to do any kind of substitution, put it in this form. But if you're going to do some kind of substitution, we're going to have it in this form. So it's going to be 1 number, 0, 1, number, 0, 0, 1, number. So what we're doing is it's almost the same thing. We both have a diagonal 1. So we're trying to get a diagonal 1. But the only thing is this is not going to be 0, 0, 0. This is going to be a number, and a number. This is what's called row echelon form. Row echelon form. Also known as Gauss elimination. Gauss elimination. So, okay, so let me start, give me another, I don't have enough room, so I'm going to use another board. So let me rewrite it as well. Let me write it again. So our matrix was 1, 3, 5, 1, 4, 2, 2, 1, 5, and then the dashed. This is a 7.5, 12, and this is 21. So we said that this is a what is it? A 3 by 4 matrix. So what our goal is, remember our goal is to put it in row echelon form. So we want a diagonal of 1, and we want everything below here 0, 0, 0, and then we could just leave these as numbers. So how we do that is we are going to use row of operation. Row of operation. It's not really hard. So in row operation, you can multiply a scalar, you can exchange rows, and you can add and subtract rows. So our goal is to get, remember we have to make this all ones, but before we do that, let's get this 0, and this 0. So we're going to do row of operation. So how I'm going to get this by 0 is I'm going to manipulate row 2 by, I'm going to do 3 times row 1, so I'm going to do 3 times row 1 minus row 2. And then this will give us our new row 2. So what I'm going to do is 3 times row 1 minus row 2. So here's row 1, so I'm going to times it by 3, and then I'm going to the whole thing, and then I'm going to minus row 2, which here's row 2. So what is 3? So 3 times row 1, so 3 times 1 is 3, right? And then minus row 2, which is, here's row 2, which is 3. So that gives us our first column, which is 0. So what about here? What would this be? So 3 times 1 is 3. 3 times 1 is 3, right? And then minus row 2, which is 4. So that's give us -1. What about here? So 3 times row 1, which is 3 times 2 is 6, minus row 2, which is, here's 1, so 6 minus 1 is 5. And then this would be 3 times 7.5 minus 12, which is 10.5. And I did this in my head, and I know it's true. So this is our new row 2, because how I got that was I multiplied 3 by row 1, the whole thing, and then I subtracted that number, whatever number I got was subtract that by row 2, which is this whole thing. So I did 3 times 1 is 3 minus 3, because that's row 2, so that's 0. 3 times 1 is 3 minus 4, that's how I got negative 1. 3 times 2 is 6 minus 1, which is 5. 3 times 7.5 minus 12 is 10.5. And then we have to bring down the original row 1 and row 3, right? So our original row 1 is 1, 1, 2, and 7.5. And then our row 3 is 5, 2, because we haven't touched that one, right? We haven't manipulated. We have to do one by one, little by little. Good. So, okay, we can make this, we can exchange this, remember our goal is to get this all 1, 1, but we don't care about right now. We can do that at the very end. But let's just first get this 0, which we already did. Now let's get this 0 and this 0. So how can I get rid of, I want to change this 5 to 0, so I'm gonna have to manipulate row 3. So what can I do to get this by 0? I can do 5 times row 1 minus row 3. So you got to figure out, you can multiply a row and then subtract an entire row, and that'll give us a new row, right? So what is from this equation? 5 times row 1 is 5, right? 5 times 1 is 5, and then you minus that by row 3, which is, our row 3 is 5, so that's minus 5. So that gives us 0, so this column will be 0. Now let's do the other part. 5 times row 1, which is 5. And then our another column minus row 3, which is 2. Right? Here's 2. Here's row 3. And that has a column 2. So 5 minus 2 is 3. So this column is 3. Okay, 5 times 2 is 10. Minus row 3 is 5. So this is 5. And you keep on going until you get to the last column, and the last column should be 16.5. And then just bring down the original column. So this is a 0, negative 1, 5, 10.5, 1, 1, 2, 7.5. Okay, so we have 1, negative 1. Let's get this 3. Let's try to make this 0. So how do I manipulate that? We still got to manipulate this row 3, because this 3 is still on that row. So how can I get to that? How can I get rid of that 3? So we can say, we can multiply 3 times row 2 plus row 3. And this will give us our new row 3. So it'd be 3 times row 2, so here's 0, times it by 3, which is 0, plus row 3, which is 3, plus, 3 times row 2, which is 0, still 0, plus row 3, so that's still 0, plus 0, so that is going to give us a column of 0. Now let's do the second column. So 3 times row 2, so that's 3 times negative 1 is negative 3, plus row 3, which is 3. Right? Do you see how I got 3 from, because this is row 3. That's how I got 3. So that gives us 0. And then 3 times row 2, which is, okay, so 5 times 3, because this is we're doing this column, so row 2 has a 5, and then times it by 3 is 15. plus row 3, which is 5. So that's going to give us 20. And then the third column is, this should give us 48. If you times it by 3, so if you would times 10.5 by 3, and then plus 16.5, that should give us 48. And then bring down the original 2 rows, so it's going to be 0, -1, 5, 10.5, 1, 1, 2, 7.5. Okay, so we got this 0, 0, 0, right? So that's part of it, so that's good. But now we just have to make this diagonal all positive 1, so we can easily manipulate that. We can do this all at once actually. So row 3, we can multiply that by 1/20. That gives our new to row 3, and then our row 2. How do we get this by positive 1? We can multiply this by the entire row by -1. And then we don't have to manipulate row 1 because this is already a 1. So we bring down the first row, which hasn't been touched, right? So it's 1, 1, 2, 1, 1, 2, and then this is still 7.5. Now for row 2, we have to multiply everything by -1. So here's row 2, multiply everything by -1. So that's still going to be 0. -1 times -1 is positive 1. -1 times 5 is -5. And then -1 times positive 10.5 is -10.5. And then row 3, we have to multiply everything by 120, by the scalar of 120. So this is still going to be 0, because 0 times 120 is 0. 0 times 0, 0 times 120 is still 0. And then 20 times 120, right? 20 times 120 is positive 1. And then 48 divided by 120, or 48 times 120 is 2.4. Good, we accomplished it. We've put it in row echelon form because we have a diagonal of positive 1 and then these as 0, 0, and 0. Right. So so remember how this column was x and this column was y and this column was z? And then these were the answers. So we said that this has a coefficient of 1, so it'd be 1 times the variable, which is z, or we could just call that z, equals 2.4. So z equals 2.4. Now we're going to have to substitute it. Substitute it by let's put it in this equation. So we know our z value, right? So let's put it in. So what is our y value? So over here, let's look at this row 2. So we have 1 times, so it has a coefficient of 1, right? And then that has a y column, so it's going to be 1y, or 1y, minus 5 by this column 5z equals -10.5. And we know our z, so we could just plug it in. So this will give us our y value. So y minus 5 times z, which is 2.4, equals -10.5. So y minus 5 times Negative 5 times 2.4 is negative 12 equals negative 10.5. So now let's solve for y, so add 12. So y equals negative 10.5 plus 12 is 1.5. Now what we can do is let's go to this row. This row. I'll put it right here. So it has a coefficient of 1, so it's 1 times x is x plus coefficient of 1, and that's a column of y. So 1 times y is y plus z plus 2z, right, equals 7.5. So we know our x, we don't know our x value, but we know our y and our z. Yes, so we know our y is 1.5 plus 2z, we know our z is 2.4 equals 7.5. So if you did the work, this is going to be x plus 6.3 equals 7.5. So subtract that 6.3 because we want to solve for x. So our x value is 1.2. So our coordinate, I'll put it right here. Our solution is x is 1.2, xy is 1.5, and our z value is 2.4. And that should equal our original equation, right? Which is 1.2, 1.5, and 2.4, right? Does that equal that? Yes, 1.2, 1.5, and 2.4. Sorry. 1.2, 1.5, 1.2, 1.5, and 2.4. 1.2, 1.5, and 2. Yes, they're true. So they are equal. So those are the two ways of solving a variable in 3 ways. So you could do elimination, or you could do the linear algebra if you're in linear algebra class. So this is one way. So that pretty much wraps it up for this section. So if you like my video, please press like. If you like it enough, you can subscribe, and if you want a video made, please comment below. Thanks.